Hi everyone, welcome to a really fun activity about graphs. So, today we're going to solve a mission that's been given to us about graphs. And the sun with 2 in the middle means that solving this mission is going to earn us 2 suns. So, each sun can be thought of as a point. Okay, so what's the mission? Draw all the graphs that have 4 nodes. And what they mean here is exactly 4 nodes. So if we want to draw all possible graphs that can be drawn with 4 nodes. And there's a hint, which is that there are less than 15 of them. Okay. So we could just, one way of going about this is to sort of just chaotically draw like different 4 node graphs that there might be. But remember, we are not just listing some 4 node graphs. We want to list or we want to draw all possible ones. And when we sort of go about it a bit randomly or a bit chaotically, then it's difficult to know that we've covered all possibilities. So we're going to go about it in a structured way. So first, let's see what's the maximum number of edges a graph with 4 nodes can have. So I have 4 nodes drawn here. And well, the max number of edges that can connect, at least for our purposes, a pair of nodes is 1. So the maximum number of edges in a 4 node graph would be the number of edges I can draw so that each pair of nodes is connected, right? So let me do that. Let me connect every pair of nodes possible and connect these two. And now the only ones that are not connected are the top left and bottom right. So let me connect those as well. And now you see that there are no more edges I can add because all the nodes, all pairs of nodes are already connected. So let's see how many edges I've added. 1, 2, 3, 4, 5, and 6. So we know now that a 4 node graph can have a maximum of 6 edges. And that makes our task a little easier because now we can divide all possible 4 node graphs in terms of the number of edges. Okay, so here's a formula that we can use. The number of 4 node graphs would be equal to the number of 4 node graphs with 0 edges plus the number of 4 node graphs with 1 edge plus the number of 4 node graphs with 2 edges and so on all the way till the number of 4 node graphs with 6 edges. Then we know that that's the maximum. So now our big task has been broken down into 7 smaller chunks, just figuring out the number of 4 node graphs with a certain number of edges. Okay, so now let's tackle these chunks one by one. Starting with the number of graphs with 0 edges. Well, this is an easy one. There's only one 4 node graph with 0 edges, and it just consists of 4 nodes. Okay, let's do graphs with 1 edge now. Okay, so let me draw 4 nodes first. And okay, I could have an edge connecting these two. That's one possibility. Are there more possibilities, is the question. Okay. I could have also chosen to connect these two vertices, right? So this is 1, 2. But here's a question. Are these two really different graphs or are they the same graph? Notice that if I just rotate graph 1 90 degrees towards the left, then I get graph 2. So there's a sense in which these two aren't really different graphs in an inherent way. They just seem to be sort of different orientations of the same graph. I could have also drawn something like this, where I connect two diagonally placed vertices. And here, I mean, rotations are not going to achieve what we want, in the sense rotating 1 or 2 is not going to give you graph 3. So yeah, it's a bit not it's a bit more complicated to see or to answer whether 1 and 2 are the same as graph 3 or not, right? So we very quickly run into problems. And this brings us to a very important question, which is, when are two graphs the same? What do we mean by same here? Let's make that a little more precise.